I'd like to now show you how to draw these energy level diagrams. And we're talking about atomic energy level diagrams, and these will be based upon the electron configurations that we've been talking about. So let's look at nitrogen first. And nitrogen has the 1s2. You'll notice the helium is over here, but it could just as easily be here as well, but it'd be 1s2. Then we go down here, this would be 2s2. Remember, this is the s block here. And then this is the p block, so that'll be the p start at 2, so that's 2p. And then we're going all the way over here to nitrogen 1, 2, 3, so it'd be 2p3. Now, what I want to do is show you how the electrons will fill an energy diagram like this one. Now, there's two ways of drawing these. You can draw them like this. We'll have energy here, and we can go this. We can go 1s, and then we'll have 2s, and then we can have 2p. Now, the way we know how to draw the number of orbitals is that for s's there's always going to be 1, for p's there's always going to be 3. That's because, remember, there's 6 electrons here. There's 2 electrons in each orbital. 6 divided by 2 is going to be 3. And likewise for D, this is the D block here. There's 10, so that'd be 5 orbitals. And for F's, that's 14, so that'd be 7. And that's how we know how many orbitals to draw. Alright, so when we're putting electrons in here, we start by going here at the 1s, and we only ever put 2 electrons in any given orbital. So it'll be 1, and that'll be 2. And then this would be 3, and this is 4. And remember, we're trying to get up to 7 here. 7 electrons. And what I'm doing now is filling these electrons from the bottom to the top. That's the Aufbau principle. And now what I'm going to do is, now that we've got these orbitals that have the same energy, I have to use Hund's rule, which states that I have to put the electrons in one at a time. And that's only when we have orbitals of equal energies. They're called degenerate orbitals. And as you can see, we've got 1, 2, 3, 4, 5, 6, 7. So that would be the electron configuration, or the atomic orbital diagram for nitrogen. The other way you'll see this expressed is like this. So instead of up down, we assume that energy is going this way, and this would be 1s, 2s, and this would be 2p. And again, we have the 1, 2, 3, 4, 5, 6, 7. So that's how we would handle something like nitrogen. Alright, let's look at something a little bit more complicated. Let's say something like sulfur. Alright, so sulfur is 16. That's the atomic number is 16. So we'll go through and we'll figure out how to do that. It'll be 1s2, right there, 1s2. And we go down here, this would be 2s2. Moving into the p block, which starts at 2, that would be 2p6. Then we go down here, this is still in the s block, that'll be 3s2. And then over here we'll have 1, 2, 3, 4, and that'll be 3p4. Remember that this always goes in numerical order. The s's start at 1, the p start at 2, so that's 2p, that's 3p, and the d start at 3, so that'd be 3d, and below that you'd have 4d and 5d, and the f start at 4, and then it'd be 4f, and then that's 5f right there. Alright, so we've got that for sulfur. Now we can draw our energy diagrams for that. And again, we'll start off at 1s. Whoops. Let's draw this beside it. And we know that energy will be going up like that. So that's 2s. Then we've got the 2p. And then we've got the 3s. Notice we get one set of energy levels for each one we've got here. We've got 1s, 2s, 2p, 3s, and now we'll do 3p. And now we put our electrons in. We've got 1, 2, 3, 4, 5, 6, 7. Now I can put these electrons in here, 8, 9, and 10. So it's always one in each first and then fill the rest of it up if you've got them. 11, 12, 13, 14, 15, and then 16. So this would be the atomic orbital energy diagram for something like sulfur. Alright, so the other way that this could be drawn, one S, 2S, 2P, 3S, and then 3P, and again filling it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16.